Hello everyone, welcome back to Diksha Karnataka YouTube channel, and in your PU2 Midterm series today I am bringing you a very important topic, which is your passing package. If you have not yet started your PU2 physics study, then don't worry. Here I am going to discuss some very important questions so that you can guaranteed you can score up to 50%, 50 marks easily. And if you are little smart and if you study everything that I am going to discuss in this video, as well as the videos that we have done in the past, then you can score up to 60 plus marks. Okay, now in this passing package, definitely it is for medium to weak students and those who have not yet started studying. Most of you are like that, so I am not going to discuss any numerical questions in this video. If you want to check numerical videos, I have done one live, so you can go and check that out. There we will be doing we have solved all the important numericals from each and every chapter. Okay, so without much delay, let me first discuss what all we are going to discuss today. I am going to discuss 20 example MCQs. Obviously MCQs, these same MCQs will not come. There are 100 different varieties of MCQs. Okay, but these are just some examples, some tricky MCQs which you might face difficulty in solving them. So those 20 MCQs I am going to discuss, and 5 example fill in the blanks. I will share some tips with you so that you don't get confused that how to answer fill in the blanks as well. Now short answer type question. Some of the short answer type questions can be 2 marker. Sometimes the same question can be asked as a 3 marker question. So there is no separation between 2 marker and 3 marker. So we are going to discuss 15 such questions, 2 and 3 marker. Okay. And lastly, long answer type, we are going to discuss 5 long answer type derivation type questions. Okay, so that you are well prepared. Everything will be very important. So watch till end, don't miss out any single question. Okay, that is my request. And for PDF, if you want to study from PDF will be shared on our WhatsApp channel exclusively. So join our WhatsApp channel. The link of the WhatsApp channel is given in the description. And if you are watching this video for the first time, don't forget to subscribe to our channel. Let's see the first question. Dipole moment is a vector quantity which is pointing from. So dipole moment is a vector quantity and it is pointing from negative to positive of the along the axis of the electric dipole. So from negative to positive along the axis of the electric dipole. So this is a correct answer. Okay, now next question. The electric potential due to a negative point charge at a distance r is. So what is the important point? Here we are trying to find electric potential due to a negative charge, okay, at a distance r. Normally electric potential is given by V is equal to K cube divided by R, right? K cube divided by R, but here we are trying to find this charge Q is negative. So negative means electric potential will be V is equal to minus K cube modulus of Q divided by R. So if you take only the magnitude of the charge, then the negative sign will come over here. So it will be negative and it proportional to 1 upon R. So it is proportional to 1 upon R and it will be negative, obviously, right? So the answer is negative and it varies as 1 upon R. Now let's move on to the next question. But before moving on to the next question, those who are staying near Bangalore or willing to relocate to Bangalore and want an offline 90-day crash course for KCET 2026 and COMEDK 2026, then Diksha presents KC90 series, where you will be getting full weekend classes in classroom setups by experienced teachers. You can crack KCET and COMEDK. To book your seat, you have to call on this number and you will get 3,000 off. Right now the festive offer is going on, 3,000 flat off if you book today. Book your seat today don't delay it. If you want online classes, we will launch online also, don't worry about it. But those who are interested in offline classes, they can book their seat today. Now let's continue with the MCQ questions. The following are the statements related to self-inductance. The self-inductance of a coil depends on its geometry and on the permeability of the medium inside it. Okay, so self-inductance L depends on the geometry and obviously mu naught or mu rather, that is the permeability of the medium inside it. It depends on its length, okay, number of turns. So geometry is important. Self-inductance is a measure of electrical inertia and opposes the change in the current in the coil. So what is the meaning of inertia? Inertia is something which tries to resist the change in motion. For example, if you are standing in a bus, okay, bus is stationary, as soon as the bus starts, you feel a pressure in the backward direction because your body wants to stay in the state of rest, right? That's why you feel a push towards the backward direction, right? Similarly, when the bus is moving, as soon as it applies brakes, you feel a force in the forward direction, right? Because your body wants to continue in the state of motion, right? We have all experienced that is a very common experience that we all have, right? So basically that is called inertia when it is trying to resist the motion. Similarly, self-inductance is something whenever you try to force a current, change the current, okay, if it is constant current then it's fine, but if you try to change the current through a coil, then what happens is that it tries to resist that change. So that's why an opposite EMF is induced and opposite current is produced in the coil. That's why it is called electrical inertia. Okay, so this statement is also correct. So both statements are correct. So correct answer is option C. Be careful, mark it properly after realizing both answers. Both statements are correct. You have to mark the statement correctly. Now next question. A ray of light is incident on glass air interface, an angle greater than the critical angle for the pair of media. Then the ray undergoes refraction only, partial reflection and partial refraction, total internal reflection, because the angle is greater than critical angle. If the angle is less than critical angle, partial reflection and partial refraction happens. But if the angle is greater than critical angle, all light will be reflected back. That's why it is called total internal reflection. Next question. Statement 1, another statement based question. The resistivity of metals increases with increase in temperature. So resistivity increases with increase in temperature. Resistivity is directly proportional to temperature. Okay, higher the temperature, higher the resistivity, higher is the resistance as well. Increasing the temperature of metals causes more frequent collisions of electrons. So electrons generally has it depends on the relaxation time. So if you are decreasing the relaxation time, then the resistivity will increase. Okay, resistivity is, remember that resistivity is inversely proportional to relaxation time. Now what is relaxation time? Relaxation time is the time between two collisions. Time between electrons is in a metal always colliding. If you have followed my lecture, you know that electrons inside a metal is always colliding with other electrons. Now if you increase the temperature, then they start to collide faster, they vibrate faster, much higher vibration. Higher vibration means higher number of collision. So both statements are correct, and basically this is the correct explanation of statement 1 as well, because this actually gives you, so you have to understand not every statement will be direct explanation. The inherent reason why it is correct explanation, because it is basically a higher number of more frequent collision means relaxation time decreases. Okay, relaxation time decreases means if relaxation time decreases, then the entire quantity goes up, because resistivity is inversely proportional to relaxation time. So both statements are correct, and it is correct explanation of 1. 2 is correct explanation of 1. So you have to be careful, not all the statements will be direct, you will not be able to understand it directly. So you have to apply certain amount of understanding. The Lorentz force is the force on a charged particle moving in a region So Lorentz force is a force when it acts on a moving charge in a region containing both electric and magnetic field. So both electric and magnetic field. So option C is the correct answer for this question. Now this is a matching question. Now matching question, there will be some cases where you know the matching, some cases you may not know the matching. So what you can do, you have to find what all matching you know. Just mark those, one or two, whatever you know, mark those, and based on that see if you find any unique combination. In case you find an unique combination, your problem is solved. For example, self-induced EMF. Okay, self-induced EMF is called back EMF. Okay, self-induced EMF means L, okay, which is called electrical inertia, which is opposes the motion. So this is basically back EMF. So we will mark this as A. Okay, so A is matching with S. Let's see how many of the matching we have A and S. So if you see the matching A with S, A with S. So two matching things are with A with S. Okay, so we have found A is matching with S. Okay, so we have found one of them. So now if there is only one option with A and S, then we could have easily marked it, this is the correct answer. But here we have two options. So definitely these two are wrong answers, so we can eliminate these two. These two are wrong answers. Okay, only we need to check the second option for the other one. Now if you see the second option, both of them have P in it. Both of them have P in it, so that must be correct because one of them is correct. Okay, so be smart, don't try to, if you are not able to answer them, just check B is matching with P. So EMF induced in a rod moving in a magnetic field is called motional EMF. So B is mapping with P. Okay, so this is already given that we even don't need to do it. Next we will say check C. Now if you come to C, you will see that C is with Q, C is with R. Okay, now let's see C, which one is matching. Can we solve it? AC generator. AC generator is the thing that we have to match, and here we know that electromagnetic induction by changing the orientation of the loop. So AC generator is basically this one. Okay, so this is the C is matching with Q, and then definitely transformer will match with mutual induction, that is also correct. Okay, now if you see that, now if you if you are not able to match anything, if you have only matched transformer, you could have answered this question. Why? Because if you see that only D matching with R is only once. So if you have matched one of them, you sometimes it is very helpful and you can answer them correctly. Okay, so we started with the first one, that's why at the end we are able to solve it. In case we have started with the last ones, sometimes that might also be very helpful. Okay, so be little bit more practical and try to find out which one, which match you need to look into. Okay, next is the average power dissipated in an AC circuit is maximum if the AC source is connected to only pure resistor. Okay, the power connected in AC circuit will be maximum if it is connected to pure resistor. In case of inductor and capacitor, power is 0, average power is 0. Okay, so the power will be maximum only when it is connected into a pure resistor or in resonance, either of them. Okay, in resonance also power dissipated will be maximum. The displacement current is due to, what is displacement current? Displacement current is basically it is a question from electromagnetic wave. Now I have not discussed the chapter, but this question as an MCQ is important. So it is basically changing electric field. So changing electric field gives rise to current, which is called displacement current. Okay, we will discuss that in future video. Statement 1, the net magnetic flux through any closed surface is 0. Yes, this is the correct statement. Statement 2, the number of magnetic field lines leaving the surface is balanced by number of field lines entering it. So if you consider a surface, a number of field lines exiting is equals to number of field lines entering. It is always correct. So that's why basically the net flux is 0. So both statements are correct, and statement 2 is the correct explanation. So both statements are correct, and 2 is the correct explanation of 1. So option A is correct. The electromagnetic waves with lowest frequency among the following are gamma rays, UV rays, microwaves, radio waves. Let's see. We are talking about lowest frequency, lowest wavelength, lowest frequency. They are opposite. Okay, higher the wavelength, lower is the frequency. So in this, all the waves that is given, radio wave has the highest wavelength. That means it will have lowest frequency. The radio waves will be lowest frequency. Gamma rays will have highest frequency. Okay, gamma rays will have highest frequency. The current density is a scalar and its unit is ampere meter square. It's a vector and its unit is ampere per meter cube. Vector and its SI unit is ampere per meter square. So current density is basically a vector quantity, and it is given by current divided by A and n cap. Okay, the direction is taken in the direction of current, but current itself is not a vector, so you have to write it like this. Okay. Anyway, this is not, you don't need to write it anyway, you have to remember it like that. Now, question number 13. A straight conductor of length I is moving with a velocity v in the direction of uniform magnetic field of strength B. The magnitude of EMF induced between the ends of the conductor is. So we have a straight conductor of length L, okay, and it is moving with the velocity v in the direction of the uniform magnetic field. Okay, strength V. The magnitude of EMF induced between the ends of the conductor, the magnitude of EMF induced between the ends of the conductor is BVL. So it is BVL. Okay. Next question. An object of finite height is placed in front of a concave mirror within its focus. So concave mirror, okay, and the object is placed within its focus, means the distance is less than f. So we will obtain a virtual and enlarged image behind the mirror. Okay, so it will be a virtual and enlarged image. Okay, so concave mirror, which is a mirror where generally we observe real images, but if the distance is less than focal length, we observe virtual and enlarged image. That property is used in many places. One of them is the shaving glass or looking glass. Okay, so if you are looking your face, makeup glass, okay, not looking glass, makeup glass, so that your face appears little bigger, right. Now next question. If the ferromagnetic material among the following is copper, nickel, lead, calcium, okay, the ferromagnetic material among the following is, which of them is a ferromagnetic material? So we are talking about ferromagnet. So copper, nickel, lead, calcium, out of them only nickel is a ferromagnetic material. It can be converted into a good magnet. Okay. Next question. In a purely capacitive circuit, if the frequency of AC is doubled, the capacitive reactance will be. So purely capacitive circuit, the frequency of AC is doubled, the capacitive reactance is given by 1 by 2 pi Fc. So if you double the frequency, capacitive reactance will be halved. Okay, it will be halved. So remember this formula, that capacitive reactance is inversely proportional to frequency. It is not a constant value, it changes with the applied AC frequency. So if you make it twice, the Xc will become half. Similarly, if you consider L, then the inductive reactance is 2 pi Fc. So if you increase frequency to double, the inductive reactance will be doubled. So inductive reactance increases with frequency, whereas capacitive reactance decreases with frequency. Now let's move on to the next question. The power factor of a series LCR circuit is maximum. So power factor or power consumed or power dissipated is maximum when the circuit is in resonance. for an LCR circuit, when the circuit is in resonance, the power factor is maximum. So power factor for the condition of resonance is that XL must be equals to XC. Okay, XL must be equals to XC. So this is the condition of resonance. So this must be the answer. Okay. This option is incorrect. Okay, let me write it like this. In the equation AB equals to C, A is the current density, C is the electric current, then B is. So in the equation AB equals to C, A is current density. So current density means J. Okay, so J current density, C is the electric field. So J into B equals to electric field, right? So this is the expression. Now in this expression we know that J equals to sigma E, that is another form of Ohm's law, but here it is given as JB equals to E. So that means J divided by sigma is equals to E. Okay, so J divided by sigma is equals to E. That means J into resistivity rho equals to E. Okay, J into resistivity rho equals to E. That means here B basically represents the resistivity. Okay, it is representing the resistivity. So option A is correct answer. Now next question. A rectangular coil carrying current is placed in a non-uniform magnetic field. On the coil, the total force is non-zero, force is 0, torque is 0, none of this. So rectangular coil carrying current is placed in a non-uniform magnetic field. So non-uniform magnetic field means obviously force is not 0, torque is also not 0. So torque is 0 is incorrect, force is 0 is incorrect, force is not 0, net force is non-zero. Net force means there will be some force in this direction, some force in the opposite direction, which will also give rise to the torque. Okay, so suppose this is the magnetic field. Magnetic field is not constant. So magnetic field not constant means the force, wherever magnetic field is more, at that point the force will be more. Wherever the magnetic field is less, the force will be less. That means there will be a non-zero force acting on this coil. Not only that, there will be a torque as well. Okay, torque will also be there. So force is not 0, torque is also not 0. Torque anyway will be there, even if the field is uniform. In case of uniform magnetic field, torque in both cases will be not 0, but uniform magnetic field means the net force will be 0. Okay. To induce EMF in a coil, the magnetic flux linking must remain constant, must increase, must decrease, both B and C. So to change the induce a current in a circuit, the flux linked with the coil must change. Change means it can increase, it can decrease. Increase, decrease both considered are as change. So both B and C is the correct answer for this question. Next, fill in the blanks. So fill in the blanks, first of all, how to answer if you don't know the correct answers. There will be some fill in the blanks that you might face where you may not know the correct answer. So what to do in that case? So always I say try to make the meaningful sentences. Okay, that will be your first target. If you can make a meaningful sentence using 2 words, that means either one of them will be the answer. So, but it will only be possible for 1 or 2 questions. Otherwise, there will be only one meaningful word per sentence. So you have to check if it is making any sense. For example, if I say I am a physics, I am a physics does not make any sense, right? But if I say I am a man or I am a boy, so that makes some sense, right? So that's what I am trying to say. I am a physics is not any correct way to form a sentence. So you have to check if it is making any formal sense. So let's see the first question. One of the basic properties of electric charges. So basically it is talking about electric charges. There are 3 properties of charges: quantization, okay, then there is the conservation of charges, and also the additivity of charges. Now let's see what property they have mentioned: the decrease, increase, quantization. So as we can see, quantization is mentioned over here. So for question number 21, the first option must be quantization. Okay. Next, so basically also if you see any other thing, it does not make any sense. So the one of the property of electric charge is decrease. Is it making any sense in language wise? It does not make any sense. That means if you just check whether it is making any sense or not, you should be able to answer such questions. Now let's look into question number 22. As the distance between the plates of a capacitor is increased, the capacitance, now in this case capacitance, so something is basically they are saying it is increased or decreased. So based on that we can say it will either, option will be either decrease or increase. So both decrease and increase is possible for this question. Okay, now let's understand. So the distance between the plates of a capacitor is increased. So distance increased means we know that capacitance is Ka epsilon naught by d. So if you increase the distance, then the capacitance must as a whole decrease. Okay, the capacitance must as a whole decrease. So decrease must be the correct answer for this particular option. The device which works on the principle of electromagnetic induction. So here they are talking about the device. Now if you see in the option, how many devices are mentioned and what are all the left options? Increase is not a device. Phasor, you might get confused, but phasor is not a device, it is a diagram. Diamagnetic, obviously not a device. AC generator, it is the only device in this given options. So even if you don't know the correct answer, you just find out what is the meaning of it. Device means some machine. Okay, if you find out what machine is mentioned in this, only electric AC generator is a device. So AC generator, we can blindly answer it even if we don't know what is the meaning of these sentences. Some cases it will be very, very helpful. A rotating vector used to represent alternating quantities is called, so it is basically called phasor. Okay, it is called phasor. Again you can check the remaining option. AC generator is done, so you can check the remaining options. Obviously is called increase, not correct. Is called phasor, may be correct. Is called diamagnetic, definitely does not make any sense. It is nothing related with magnetism. So alternating quantities is called phasor. So phasor is the only correct option that can be a possible answer. Just by using the logic of language we can answer this. The magnetic susceptibility is negative for dash materials. So here we are talking about magnetic materials. So there are three types of material, and in the option only one magnetic material is mentioned, that is diamagnetic. So we will close our eye and we will just simply put diamagnetic. Okay, even if we don't know if it is negative or positive, but just by checking the options we can answer it. Now in the case if diamagnetic and both paramagnetic are given, in that case you have to be careful and you have to know exactly for which material it is negative. Okay, so for example there will be one question where this kind of confusion might happen. So be careful about that, otherwise you can easily answer such fill in the blanks questions. Now let's move into 2 and 3 marker questions category. So first question is state and explain Coulomb's law, or write Coulomb's law in vector form, explain the term. So both questions are possible, same concepts, same question, only the way you answer them may be vary. So state and explain means you have to write the statement and you have to write the expression. The vector notation is not necessary in this case, but you have to write f is equals to 1 by 4 pi epsilon naught q1 q2 by r square. That portion you have to write. You have to explain what are all the terms. But if they only ask you write it in a vector form, then only this much is sufficient, along with the diagram. In the case of in the diagram, what you have to draw? You have to draw two charges q1 q2 and they are separated by a distance r. Then you have to show that r cap is a unit vector in that one of such direction. Okay, you have to draw this, you have to show this to get an idea that to tell the teacher, okay, this is the idea of vector form. okay. This is r cap, okay. So you have to show it to the teacher, saying that okay, I am saying this is one of the vector. Also one more way is that f12 equals to minus f21. If you mention that, that will also be very, very good, okay. Now there is a same answer is given in your textbook also. You can draw that diagram as well, but that answer is slightly complicated. This is the easiest way to represent, okay, but diagram is compulsory in case of vector notation. Now what factor does the capacitance of a parallel plate capacitor depend? So what are all the factors on which capacitance of a parallel plate capacitor depends? It depends on the area. So capacitance is directly proportional to area, okay, inversely proportional to distance between the plates. So it is inversely proportional to the distance between the plates, directly proportional to the dielectric constant kept between the medium. So it is directly constant with the dielectric constant. So these are the three things you have to remember. Now next, when does a current carrying conductor placed in an uniform magnetic field experience maximum force, minimum force, okay. So we know that force acting on a current carrying conductor is BVL sin theta, okay. So the force will be maximum when sin theta is equals to 1, force will be minimum when sin theta is equals to 0, right. So when the current is flowing perpendicular to the direction of the magnetic field, so that is in this case theta is equals to 90 degrees, sin theta, sin 90 is 1. So this will be maximum force, minimum force when the current flowing in the direction of the magnetic field direction or in the opposite direction, you might say. So in this case the theta is equals to 0, okay. In that case it will be minimum. Minimum is possible in theta is equal to 180 degree as well, but maximum is only possible at theta is equal to 90 degrees, okay. Now next, state Faraday's law and the Lenz's law of electromagnetic induction. Both laws might come, or individually one of the laws might come as a 2-marker question, okay, or individually combined as a 3-marker question might come. If they ask you explain it, then you have to add this mathematical expression epsilon is equal to minus d phi by dt, okay. It is induced EMF, it is rate of change of induction. So Faraday's law, the time rate of change of magnetic flux through a circuit induces EMF in it, okay. The time rate of change, so this is called time rate of change of flux, okay. Lenz's law, the polarity of induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produces it. So this is negative sign signifies that the direction of EMF is actually opposite to that of the cause which is producing it. That's why it is negative, okay. So this is Lenz's law and Faraday's law. Mention 2 limitations of Ohm's law. Very, very important question. It can come as a 3 limitation as well as a 3-marker question. So I have given you 3 options. Any 2 you can write for 2-marker. For 3-marker you have to write all 3 of them. Ohm's law is applicable only if all the physical conditions remain same. Yes. So all the physical condition means suppose you are using a copper wire, you are sending some current through it and suddenly the copper wire melts. So if the copper wire melts, then definitely Ohm's law will not be applicable. So all the physical condition has to remain the same. Ohm's law is not applicable at very low and at very high temperature. So Ohm's law is if the temperature is very high or very low, Ohm's law cannot be applied. Ohm's law is not applicable to non-ohmic devices like semiconductor devices, discharge tube, etc. So Ohm's law cannot be applied in such cases. Next is write any 3 properties of electric charges. So additivity of charges. Charges are additive in nature. Quantization of charges. All charges. Charges are additive in nature means they can be added like scalars. Okay, simple scalars, 2 plus 2 4, 2 minus 2 0, that is simple addition. Okay, vector addition is different. Okay, vector addition you have to consider the direction as well. 2 plus 2 is not always 4 in vector addition. Okay, for example, if you consider 2 and 2, it will be 2 root 2. Okay, so there we used to joke around that when 2 plus 2 is not equals to 4, when the quantities are vector quantities and they are not in the same direction. So in that particular case, 2 plus 2 is not always 4, right? Quantization of charges, all charges are integral multiple of smallest charge. E is 1.6 into 10 to the power of minus 19. All charge that you measure always has to be the integer multiple. It cannot be a fraction, it always has to be an integer. Conservation of charges, total charge in an isolated system is conserved. Very important to remember, it is conserved for only isolated system, not for any system. System has to be isolated, then only charge is conserved. This derive the relationship between electric field and electric potential due to a point charge. So let us see, here we have to consider two equipotential surfaces, namely A and B, two equipotential surfaces. Okay, the electric field is pointing from higher potential to lower potential. So always remember that electric field always points from higher to lower potential. Okay, now the distance between these two equipotential is delta L. So you have to write that, let us consider two equipotential surfaces A and B. Okay, now what? Now you have to write it like this, that to bring a test charge from test charge Q from A to B, the work done will be. So first let us understand what we are trying to do, then we will explain it. We will do the mathematics. Basically we have a test charge Q here. Okay, we are trying to bring this test charge from A to B and we are trying to calculate the work done. Now work done can be calculated in two ways. Okay, there are two different ways to calculate the work done. There is one way which is mechanical way that we have learned in our PU1, right, that work done is basically force into displacement. That is dot product of force into displacement. If they are in the same direction, then it will be simply F dot S, Fs, right. If they are in the separate direction, Fs cos theta comes. But here, as we can see, we are moving in the direction of electric field, so F into S will be the work done. And one definition of work done that we have learned in our second PU, where we have learned that it is basically potential difference times the test charge. Potential difference times the test charge gives you the value of work done to move from one point to another point. Okay, so we will use that both formulas here to calculate the work done, and then we will compare. So to the work done is basically given by, first of all, F into delta L here. Okay, F into delta L, and that is also equals to final potential minus initial potential. This is how we calculate the potential difference times the test charge, which is Q. Okay, so this is the formula. This is how you should approach final potential minus initial potential. We are moving from A to B, So B is final potential V dot A, right, and initial potential is V over here, right. So this is how we calculate. Now here F dot delta L, we have to find F as well. So when you keep a charge of Q in an electric field E, then the force acting on it is given by Q into E, right. I told you multiple times, if you have followed any one of my electric charges lecture, okay. So force is always equals to Q into E, okay. Force is always equals to Q into E. So Q into E is basically times delta L equals to minus, so V cancels, minus delta V left into Q, okay. So this is the formula. Now Q cancels from both sides, so electric field E equals to minus delta V by delta L, okay. This is the relationship between electric field and electric potential. This is electric field, this is electric potential. Okay, more accurately we can write this as Ex equals to minus dV by dx. This is a more accurate term, okay. We will discuss, we will learn about this symbolism etc. in later on, but I am not discussing that right now. Now let us see next question. State and explain Biot-Savart's law in a suitable diagram. Okay, first you have to draw the diagram as well. Here as you can see the diagram, here we have a current carrying wire. Okay, we are trying to find the magnetic field at point P. Then what we have this arrow. This arrow represents the direction of current element, ideal. Okay, here it is the direction of the point P, and dB is the magnetic field, which in this case happens to be into the page of the paper, because current carrying it will be if you apply right hand rule, it will be the direction of current, then the direction of magnetic field will be into the page of the paper. Okay. Now the magnitude of magnetic field dB at any point P due to the current element dl is given by is directly proportional to current I, is directly proportional to the length of the element dl, it is directly proportional to the angle sin theta that is being between the direction of element and the direction vector, okay, position vector. Now if you draw the diagram, then you don't need to explain the terms, that is one important part, and dB is inversely proportional to 1 upon r square. Combining all of them, we can write dB equals to mu naught by 4 pi I dl sin theta by r square. This is the combined final form of Biot-Savart's law. Okay. Derive the expression for motional EMF induced in a straight conductor moving perpendicular to uniform magnetic field. So here we have a rail line. Okay, you can consider this to be a rail line, but the rail line generally do not have any connection. So here we have connected the two sides of rail using some conductor. Okay, normally rail lines they are not connected using conductor, but here we have a connection between the conductor and here the line ends. Okay, here you can consider this to be a railway a track of straight line track, conducting track, which is connected with the rail line track through some metallic conduction, and it is moving with a velocity towards this direction. Magnetic field lines, magnetic field exist here, and that is into the page of the paper. Cross signifies into the page of the paper, dot with a circle represents out of the paper, if you forget. So now we have to find what is the induced EMF at these two ends. That is the basic derivation. Diagram is compulsory in this case. So at some distance, at particular some distance x, okay, what is the flux linked with this circuit? Okay, what is the flux that is passing through this particular area? This is the important part. What is why? Because this is the area that is in play here. This area is not out of the play because only this portion is completing the circuit. So completing the circuit is always very essential for the current to pass, right? To measure the induced EMF current has to pass, right? So this is the closed circuit, so we have to calculate the EMF based on this. Now what is the flux linked with any circuit? Flux linked with any circuit is basically given by the magnetic field times area. Okay, there is a cos theta involved, but here the direction is perpendicular. Okay, so we will not we are not considering the cos theta term over here. Okay, they are velocity and area area and magnetic field are in the same direction, so cos theta is 0 in this case. Okay, that's why we are not considering the cos theta term over here. Okay, now velocity is a perpendicular definitely, but area and B are in the same direction. Now what is the magnetic flux over here? Flux is magnetic field into area. So what is the area in this particular case? So it will be the area is given by length times the distance, length times the width. So this is length, this is width. So we can write this as B into L into X. Okay, BLX is the flux. Now what? Now we have to find the induced EMF, magnitude of induced EMF. So magnitude of induced EMF is basically d phi by dx. Okay, magnitude, that's why you are not taking the negative sign. So let's do the derivation, d dx of BLX. Now obviously magnetic field given in this question is constant, the length L is constant, only what is changing is this. Sorry, there is a mistake. It is rate of change of time with respect to time. Okay. So it will be ddt. Sorry. So the flux has to change with time, not with x. So dx by dt. Okay, dx by dt is the induced EMF. Now what is dx by dt or dx dt? So dx dt, if you remember in your first PU, the velocity of any particle is given by dx dt. Right? This is the differential definition. Now back then you have no idea about differentiation, and the teacher in the physics class was teaching you, and you may have disconnected yourself, slowly started hating physics, right? Many students face this kind of issue, so that's why you should not approach too much with this method in your PU1, but once you have done with all the differentiation and integration, then you can come back and revisit those concepts. That is the very important part. Now write 3 differences between diamagnetic, paramagnetic and ferromagnetic material. So, so the difference, this is a common difference table. If you remember this table, you can answer all the difference, any combination, dia, para, ferro, ferro, dia, all combination of questions can be answered through this only single table. That's why it is very important to remember the entire thing. So property, magnetic behavior, diamagnetic, these are weakly repelled by magnetic field, these are weakly attracted by magnetic field, these are strongly attracted by magnetic field. Magnetic susceptibility, have a small negative magnetic susceptibility, that is susceptibility is less than 0 for diamagnetic, susceptibility is slightly positive and it is greater than 0 for paramagnetic, and for ferromagnetic susceptibility is very high and it is greater than 0. Now this symbol is correct, these two symbols are incorrect. Okay. Effect in a magnetic field. So if you keep in an external magnetic field, induces a very weak magnetic field in the opposite direction of the applied field, induces a very weak magnetic field in the same direction of the applied electric field, induces a strong magnetic field in the direction of the applied field for ferromagnetic substance. Okay, I hope it will be very helpful for you. Now obtain the expression for effective capacitance of two capacitors connected in parallel. So here we are going to derive the parallel combination of capacitor, often very important, and only two capacitor is required, you do not need to add the third one. So read the question. If they do not mention anything, you can do 2, 3, 4, 5, as many as you want, but if they mention only 2, then why should you go for 3? we just need to do 2. Okay, 2 is minimum. So C1 and C2 you applied a voltage source V over here. The charge through this is Q1, charge through this is Q2. Okay, so this is the combined circuit. Now what is the equivalent circuit? So for equivalent circuit, what you have to do? You have to replace everything with only one single capacitor. Right. So this is the normal circuit. Now if you replace it with an equivalent circuit, then for equivalent circuit there will be only one capacitor. Okay. And because it's a parallel combination, that means the charge Q1 Q2 is passing through this, that means Q1 plus Q2 must be the total charge in the circuit. So once you have replaced it with C equivalent, the total charge will be Q1 plus Q2, okay, and voltage will be remains the same, that is V. Okay, now what you have to do, you have to find a way to find the C equivalent. Now what to do? We know that in parallel combination the voltage remains same for each of the capacitor. So from that we can say V is equal to Q1 C1. Okay, now let's calculate the value of Q1. So Q1 equals to I made small mistake. For capacitor C1, Q1 equals to C1 V1. Okay, this is the formula. Similarly for capacitor 2, Q2 is equal to C2 V2, and for the equivalent capacitance Q1 plus Q2 must be equals to C equivalent into V. Now in parallel plate capacitor the voltage must remain same for all the capacitors, so that means all voltages must be same in all the capacitors. Okay. Now what we will do, we will put these two Q1 Q2 values in this equation and just add them. C1 V plus C2 V equals to C equivalent into voltage. So voltage will be common, so C equivalent equals to C1 plus C2. This is the equivalent capacitance, okay, for parallel plate. Okay. Now next, write three properties of electric field lines. Electric field lines may start from positive charge and end at negative charge. Two electric field lines are never intersect each other. Electrostatic field lines do not form any closed loop. So these are the very common easy properties, electric field lines properties. Write two properties of equipotential surface. No work is done. 2 to 3 properties you have to remember. For properties, always remember 3 properties, so that in case it is coming as a 3 marker also, you can answer those questions. No work is done in moving a test charge over a equipotential surface. Electric field is always normal to the equipotential surface at every point. No two equipotential surfaces can intersect each other. Okay. Mention any 3 properties of magnetic field lines. The magnetic field lines of a magnet form continuous closed loops. It is different than that of an electric field, by the way. The tangent to the field at the line given at a point represents the direction of net magnetic field at that point. The magnetic field lines do not intersect. If they do, then the direction of magnetic field would be not unique at the point of intersection. These are the very 3 common points. Again, except these 2 points are common for electric field. This is not common for electric field. Electric field do not form closed loop. Magnetic fields always form closed loops. Mention any 3 energy losses in a transformer. Flux leakage, there is always some flux leakage, that is not all the flux due to primary passes through the secondary. Resistance of the windings, the wire used for the windings has some resistance, and so energy is lost due to the heat produced in the wire, I square R. Eddy currents, alternating magnetic flux induces eddy currents in the iron core and causes heating. The effect is reduced by using laminated core. Laminated core means, so instead of using a single block of transformer core, single block, generally transformer core looks like this. Okay, instead of using a single solid block, what they do, okay, they make it very thin slices, okay, slices, and then they laminate it. Laminate means they cover it using some paint, okay, some liquid paint on each of those pieces, so that they are insulated from each other. They do not come in contact with the next slice, very thin slices. Then they add varnish paint or some glue, okay, so that they stick to each other, but they do not have any electrical contact between them. That is one of the way to reduce eddy currents. Eddy current is basically due to the self inductance of this core material. Okay, due to the self inductance of the core material, there will be a current which is induced in the circuit, okay, and that current will heat up. And who will provide that heat energy? It must be provided by the supply energy, right? So basically you are losing out the some energy due to this. So these are the all 2-3 marker question. Now let's move on to the 5 marker question. Derive the expression for electric field at a point due to an infinitely long, thin, uniformly charged straight wire using Gauss's law. Now, I am doing only 5 derivation. If you can practice 5 more derivations, okay, I have shown them in my other lectures. You can go and check them out, but these 5 you cannot skip. These 5 are must. If you study these 5 derivations, you will be able to answer 2 of the derivations that you need to answer. Okay, that much is clear. But I request if you can practice 2 more, so that practice 5 more, so that in case the question paper is slightly difficult, then also you can answer the question. Okay, so here is a straight wire and it is charged. Now we are trying to find the electric field at some distance from this charged wire. Okay. So for that, first of all, we have to construct a Gaussian surface of radius r. It will be a cylindrical Gaussian surface. All the field lines will always pass through the curved surface only. No field lines will pass in these directions. So only thing that we need to consider is the curved side of the cylinder. So suppose the length or the height of the cylinder is L. Okay, we are assuming the height of the cylinder is L. The line charge density of the wire is lambda. Now this is an infinite wire, that means there is no point of having the total charge. Okay, total charge will definitely be infinity, but line charge density, if we know, that is unit length per unit length, the charge is lambda. Now we will apply the Gauss's law. So what is Gauss's law? Gauss's law states that E dot ds, okay, E dot ds equals to charge enclosed divided by the epsilon naught. This is the now in this question, if this question comes, there will be always accompanied question that state Gauss's law and hence prove. So Gauss's law statement is that the electric flux passing through any closed surface is basically equals to the charge enclosed by the surface divided by epsilon naught, or times 1 by epsilon naught, whatever you are comfortable with. So statement of Gauss's law you have to remember. Now E dot ds equals to q enclosed by epsilon naught. Now here E and ds both are in the same direction. This is the direction of ds, this is the direction of electric field. Positive charge means inward, negative charge, positive charge outward, negative charge inward, but in both cases E and ds will be in the same direction. So what we can say that this will be simply EDS integration Qn, because cos theta is 1. That's why dot product simply gone. Okay. Now E has a cylindrical symmetry. Cylindrical symmetry means all the points on the surface of this cylinder, the magnitude of E must be constant, because there is no involvement of any other terms. That means if the ds is constant for a particular ds along this ds, okay, then the electric field has to be constant on the each point on this cylindrical surface. So that means E is constant. So E constant means magnitude wise, direction will change, magnitude wise it is constant, so it will come out of the integration. We will get ds equals to q enclosed divided by epsilon naught. Now what is q enclosed? Q enclosed is the charge which is enclosed by this cylinder. So charge enclosed is the line charge density times the length of the cylinder. So that means it is lambda L by epsilon naught. Remember it, even if you forget, once you have come to this stage, you will remember that okay, I have to put the value of Q enclosed as well, which is nothing but length of the cylinder times the line charge density. Right. Now E into ds. So what is this closed integral ds? Closed integral means if it is closed integral of length, that means perimeter. Closed integral of area. Closed integral of area means it is the total surface area. Closed integral volume means it is the total volume of the object. Okay, here ds means total surface area of the object. Now in this case, obviously top and bottom surfaces we will not consider because electric field does not exist in these two directions. So only the curved surface area we will consider. So what is curved surface area of a cylinder? It is nothing but 2 pi radius into length, that is 2 pi RL. That is sorry, not 2 pi RL. Yes, 2 pi RL is the not 2 pi RL is the area of the curved surface of the cylinder. So that is basically lambda L by epsilon naught. So L cancels and you get electric field E equals to 1 by 2 pi epsilon naught lambda by R. So as you can see, in this particular case, electric field is not inverse square of the distance but only inverse of the distance. So that is also very important point to remember. So this derivation is tumba important, so practice madi, and if you have any doubts please mention in the comment. Define electrostatic potential due to a point charge and arrive at the expression for electric potential at a point due to a point source charge. So what is the definition of electric potential? Definition is basically the work done to bring a unit positive test charge from infinity to a point in the electric field. Okay, that is called the electrostatic potential at that particular point. Okay, remember the statement. If you want, you can rewind it and write it down on your own words and then write it in the exam. Okay. Now the derivation that we are going to do is very important. Here we have a charge, say capital Q, and we have this is our point of inspection. Say this is our point of inspection P. This point we are trying to find the electric potential. Okay, for that we have to start at a point which is at infinity. Okay, we will start at a point which is at infinity and we will take unit positive charge, or we can take any charge Q also, because unit positive test charge means we have to divide final result with Q. If you take a charge Q, it sometimes is very easy. So you take a test charge small q and bring it from infinity to this point P, then you have to calculate the work done. Now infinity is very difficult for us to handle. Okay. So what we will do? We will not go to infinity, we will take some intermediate point. This point is neither infinity nor our destination. So destination is at a distance of r, but this point is at a distance of x. Okay, this point we do not know exactly where it is. So suppose we have started we started from New Delhi, we want to reach Bangalore, but in between some station, say Solapur or say Gulbarga, there the train has stopped. So this is basically somewhere in between. It is neither stuck at New Delhi or nor it has reached to Bangalore. Okay, so this is the somewhere where it is in between point. Okay, so this is called in between point, and generally we take it using a variable x. Okay, so this point, say A. At this point A, and we will move it by a small distance. We will move it by a small distance dx. Okay, say point B. Now you will try to calculate what is the work done to bring this charge from A to B. Okay. So what is the force acting on this charge Q? The force that is acting due to this is basically the electric field times Q. This is the force that is acting on this charge. To overcome and move the charge, you have to apply an external force which is basically opposite to this internal force. Internal force is Q into E. So external force has to be opposite to that of the internal force. It will be opposite direction of the internal force. That's why negative sign comes in and it will be minus Q into E. So what is this E electric field? Electric field is K charge divided by distance square, right? Now let's put that. So minus K Q by R square. This negative sign is very, very important to remember. Okay, many students forget it and at the end they get a negative answer, which is not correct. So this is very, very important. Now what is work done? Definition of work done: to bring a charge by a very small distance dx, the work done, small work done dw must be the external force that you are getting applied, that you are applying on this, times the displacement. Now both are in the same direction, so we are saying force external into dx. Okay, so that is basically minus kq by r square into dx. Sorry, one mistake I made here. Here the force is not r square. Force will be r square when it is at P. Here it is at a distance x, so force will be x square. Okay, it will be x square, not r square. R square will be if we go to point P. Okay, but we are somewhere in between point which is at a distance x, so the force will be x square divided by x square. So this is the total work done. Now to calculate the total work when we are starting at infinity and reaching this point P, to calculate the total work done, there is a way in physics and in mathematics when we do integration. So where we are starting, our starting point was at infinity and our final destination is at a distance r. So x basically has to be in between these 2 points. That is the way to construct. You can once you go to higher classes, this kind of integration you have to construct yourself and solve them. Okay, so that basically means you have to take 2 points and in between these 2 points you have to take an arbitrary point. This is called an arbitrary point. Okay, now let's put these values. Infinity to r, it will be minus kq by x square dx. I hope integration is already done in your class, so you are familiar. So minus k capital Q small q are constant, so it will come out of the integration. Integration infinity to r dx by x square. So this is an easy integration, not super difficult. So you get this as minus kq minus 1 upon x infinity to r. Okay. So this minus and this minus will come out, this minus will come out and it will cancel. So k capital Q into first upper limit 1 upon r minus the lower limit. Okay, instead of x we will first put the upper limit, next we will put the lower limit. Okay, the negative sign already we have taken common, so negative sign is no longer here. Now 1 by infinity is basically 0, so we can write this as k q by r. Now this is the total work done. Total work done. Now what is electrostatic potential? Electrostatic potential at a point is defined by total work done divided by the charge, test charge. So it will be k q by r, or it will be 1 by 4 pi epsilon naught q by r. So this is the electrostatic potential at a distance p. So this is the formula, this is the derivation. If you do all the steps, you will get full marks. This is a very important derivation. Okay, this derivation has come almost each and every year. So you have to practice this derivation multiple times. Derive the expression for refractive index of the material of the prism in terms of angle of minimum deviation and angle of the prism. And now this is slightly tricky but very common. That's why I recommend this to students. Okay, this is a very common derivation. Now here you have to practice these two diagrams. Super accuracy is not needed, at least the basic understanding you have to do it. This graph you have to draw it a little bit carefully, okay, so that there is only one point where it makes a maximum point. Now at this point you have to draw these dotted lines as well. Practice this diagrams 1-2 times, that will be ideal for you to remember. Okay, now there is not much super difficult in this case. Everything you can remember it. If you are good in memorization, you can memorize it. Otherwise you can check the geometrical proof. Geometrical proof is not required. You just need to mention that from geometry you can write that delta equals to, delta is the angle of deviation, normal angle of deviation, not minimum deviation. Okay, normal angle of deviation can be written as I plus E minus A. Okay, and the angle of prism A equals to R1 plus R2. By observing I versus delta graph at this point, we can see that the angle of minimum occurs when the angle of incidence I is equal to emergent angle E. So if you see, this is the deviation, angle of deviation graph. Okay, angle of deviation graph. So all the points are higher than this point. So this is the point where angle of deviation is smaller. Okay, smallest in fact. This is called minimum angle of deviation. So at minimum angle of deviation, if you consider you draw a tangent, this will give you the angle of deviation, and this will give you the two angle of incidence and emergent. Now here only one possible angle is there, that means angle of incidence and angle of emergent both has to be equal. So that means I must be equals to E, and if I is equals to E, their respective internal angles will also be same. So R1 also has to be equals to R2. So we are saying E equals to I and R1 equals to R2 equals to R, right? So delta minimum means now we are using the same equation here. Instead of delta, we are using delta minimum. So delta minimum equals to I plus I, because E is also I. So I plus I 2I minus A. Same formula, we are just using the values. So from there we can write I is equal to A plus delta M by 2, and if you use the second equation, you will get R equals to A by 2. Now we know that refractive index of any material is given by sin I by sin R from Snell's law. So N21 for the material of the prism, N21 is given by sin I by sin R. Just put the value of sin I and sin R. So that is the basic value of refractive index of the prism. Easy derivation, very commonly asked in the midterm exam. That's why I included this derivation in this lecture. Arrive the balanced condition of Wheatstone bridge using Kirchhoff's rules. So you will first have to draw the circuit diagram. Kirchhoff's rule is also very super important topic, not only for your midterm but also for your board exam. So first you have to draw this. Now I am going to teach you a very shortcut, easy trick, easy method to solve the Kirchhoff's junction. So P, so this is say Q, this is say R, and this is S. This is the galvanometer G. You connect this to a battery. Now remember that when the Wheatstone bridge is in balanced condition, in that case the current through the galvanometer Ig must be equals to 0. So if this current is I1, then in the balanced condition the current through this will also be I1. Okay, so if this current is I2, no current passes through this, means the current through this will be also I2. Now you have to write this statement. Without writing, you cannot use the shortcut trick. So in balanced condition, and diagram is compulsory. Ig must be equals to 0. Therefore, the current through P and Q must be same. So, in this case it is I1. Similarly, the current through R and S must be same. This is I2. Okay. Now we will apply. So, say A, B, C, D. Okay, you have to mark them so that you can apply it. Apply Kirchhoff's laws. So, applying KVL or Kirchhoff's loop rule for loop. This is the symbol for loop. A, B, D, A. A, B, D, A. Okay, A, B, D, A. No current is passing through this. So, we are taking the current through this is 0. We will only take the current through this AB junction and DA junction. Okay. So, what is the current passing through AB? Current passing through AB is I1, and what is the resistance between them? Resistance is P. So, resistance time current. Okay. Now, there is no current through this. So, G into 0. So, you can mention that G into 0 over here plus or minus. We will see that now you are going from D to A. So, A, B, D, A. The direction is very, very important whenever you are applying Kirchhoff's rules. Okay, here you are going from D to A. So, I2 is in this direction, but you are going in the opposite direction. So, that means it will not be positive, but it will be a negative sign. So, you have to write minus R into I2, and that must be equals to 0. Why 0? Because if you see that there is no battery is connected or no cell is connected in this junction. Cell is connected outside this loop. So, no loop does not have any battery. So, no battery means simply 0. So, from here we can say P into I1 minus R into I2 equals to 0, or P I1 equals to R I2, or I1 by I2 equals to R by P. Okay, I1 by I2 equals to R by P. Okay, next we will apply the same principle of KVL at loop BCDB. BCDB. Okay, now what will happen in this case? Again same thing, I1 into Q minus I2 into S, and there is no current here. So, simply we are not writing it over here. So, it will be equals to 0. Okay, I1 into Q minus, why minus? Because we are going in the opposite direction of the given current. So, it will be I2 into S, but minus, and in this case Ig is 0. So, nothing is there and no cell is connected in this loop as well. So, it will be equals to 0. So, from here we can write I1 by I2 equals to S by Q. So, this is equation number 1, this is equation number 2. Comparing 1 and 2, we can write R by P equals to S by Q, or P by Q equals to R by S. So, if you cross multiply, P goes here, S comes over here. So, P by Q is equal to R by S. This is the required derivation, required condition for Wheatstone bridge balance condition of Wheatstone bridge. Very simple, easy derivation, not super rocket science. There are different long derivations given in your textbook. I know many of you will not follow my simple derivation, they will use their memorizing tool which is given in the textbook. But if you understand this, if you try to remember this and practice this 2-3 times, it is very, very easy for you to remember. Now, next. Derive the expression for the magnetic field at a point on the axis of a circular loop. This is also very, very important derivation. Here we have a loop. We are trying to find the magnetic field at some point P. Okay, this is also almost coming almost every year. So this point is P at a distance x from the center. The radius of the loop is r. Okay, we are considering a small element dl over here. Okay, dl is in this direction, so this angle is 90 degrees. Okay. Now, if this angle is theta or say phi, then the magnetic flux, whatever it will make an angle, it will make an angle phi with this. This is the magnetic field dB, and this is magnetic field dBx. The magnetic field along the y axis, they will cancel. If you consider the entire circular loop, there if you consider dl here, dl and dl over here, the magnetic fields, they will cancel each other. So there is no effect of the magnetic field along the y axis, only the x axis magnetic field will be there. Now first we will apply Biot-Savart's law and we will see what is dB is. dB is mu naught by 4 pi I dl sin theta is 90 degree over here, I dl sin theta by r square. So in this case r is basically this. This is r, not this r. This is not r. R is the direct distance between the current element and the points, which is r. Okay. So this is the r square. This is the Biot-Savart's law. Simple Biot-Savart's law we have applied to calculate dB. But dB has two components. One is along y axis, one is along x axis. Y component we are not interested. Only x component will be actually we are interested. So dBx equals to mu naught by 4 pi. Okay, I dl by r square into dBx means cos phi, cos component. Okay, so I dl by r square cos phi. Now put the values everything and we will finally calculate the total magnetic field. So mu naught by 4 pi, okay, I into dl. Now what is r square? You see this is a right angle triangle, so r square is basically a capital R square plus x square, right? This is the right angle triangle, perpendicular and perpendicular and base. This is hypotenuse, so it will be square root of r square plus x square. But there is a square also, so it will be square root of square. So anyway, it will cancel. We will see that. Now what is cos phi? Cos phi is basically base divided by hypotenuse. So it will be there is one mistake I made. This angle is not phi. This angle will be phi. Okay, this angle will be phi. Then this angle will be phi. Okay. Now cos phi is basically base by hypotenuse. Base is r in this case and hypotenuse is small r. Small r means the same thing. Okay, small r means the same thing. So let me do one thing. Let me not put the value of r over here right now. So it is r square, it is small r. Now let's simplify. It will be mu naught by 4 pi I r dl divided by small r whole cube, r square into r small r whole cube. Now what is small r? Small r is square root of r square plus x square, right? Now what we will do, you will calculate the total magnetic field. Very, very important. Total magnetic field Bx equals to integration dBx, close integration dBx. Close integration means we are starting the point and our ending point both are same. starting and ending point same means that will give us the closed integration. Now we will put the values. So obviously mu naught is constant, 4 pi is constant, I is constant, divided by this is also constant, r and x, even though x appears to be some variable, it is not variable, it is constant in this particular case, and we can write this as r square plus x square to the power 3 by 2. Power 3 is coming from this bracket and half is coming from the square root. Okay, but there has to be some integration. What integration we are doing? We are doing the integration for this element dl. Okay, so this is the integration for this element dl. So we have put the value of dl over here. Now so bx equals to mu naught by 4 pi I by r square plus x square to the power 3 by 2, okay, into closed integral dl. Closed integral dl means what? What I said, close means either total surface area, total perimeter. In this case, because it's length means perimeter. So perimeter means it will be 2 pi r. So it will be 2 pi r. Okay, so 4 pi 2 pi cancels, so you get bx equals to, there was one r here, okay. So I r square mu divided by 2 into r square plus x square to the power 3 by 2. So this is the final expression for magnetic field. Okay, remember it is only x component and you have to calculate the x component only. Practice this derivation. This is a little tricky initially, so you have to practice this derivation 2 to 3 times at least, so that you can answer, you can get a hang of this particular formula. You can remember it like this as well. Bx equals to mu naught by 2 I r square divided by r square plus x square to the power 3 by 2. This is also you can remember like this. Okay. So this is the end of today's lecture. If you are liking our videos, please don't forget to subscribe to our channel, share this video with your friends. Also give this video a like so that we get inspiration to make more such video. I'll be back with more midterm videos. Till then, bye.